This video is about the Arrhenius definition of acids and bases. Arrhenius, this was, I don't know the exact date, but a while ago, was someone who, was first kind of credited with looking at what makes an acid chemically. So acids, Arrhenius noticed that the acids produced ions, and those ions were able to conduct electricity. So, according to Arrhenius, any compound that will give off those hydrogen ions, which would then increase the concentration of hydrogen ions when added to water, that's what an acid is. And then this is where we first can start talking about hydronium. So if something gives up a hydrogen ion, that hydrogen ion will become attracted to water, because this would be in an aqueous solution, so there'd be water around. And because water has such polarity, it has that very negative electronegative oxygen, this hydrogen will just attach onto water and form H3O, which is positive. It's no longer neutral. And that's what's called hydronium. So not all hydrogen atoms in a compound are going to be released or, are ionizable. So, for example, methane, those hydrogens do not come off. And acetic acid, it's just this one hydrogen here, and you're going to learn more about that. So these other hydrogens are not going to come off, so those are not ionizable. An Arrhenius base is a compound that will increase the concentration of hydroxide when we add it to water. That's the Arrhenius's definition. So examples of bases that are solid on room temperature, but when you dissolve them in water, then they break apart and give those hydroxide ions. So sodium hydroxide, potassium hydroxide, they're all hydroxides, magnesium hydroxide. Some of these are found in antacids and what we take if we have an upset stomach, because a lot of times we have too much hydrogen. Also, sodium hydroxide, we can use that in drain cleaners and things because bases are very corrosive, and they, we know that soap helps dissolve like oils and things from our skin. An extreme case of that would be Drano, which is dissolving all of those hairs and oils and food and things that are in our drains. So, sodium hydroxide, here's the slide that kind of talks about that. It can be used for a lot of different things, sometimes just thickening ice cream or olives, getting them to turn black. But if it's in the pure form or almost pure form of like a drain cleaner, it can be pretty nasty stuff. In fact, this is not me, but it does cause like a caustic kind of burn. It's also known as lye. So originally, the soaps that were produced, hundreds or so more years ago were produced from lye, and they were so basic, they didn't cause this, but they were definitely really irritating for the skin. So in the early 20th century, Arrhenius's model was kind of incomplete and didn't quite define it didn't allow certain other things that were acids and bases to be considered an acid and a base, if that makes sense. But it will, once we get to another day of learning, when we learn about Bronsted-Lowry definition, it's a much broader definition, allows more things for us to discuss as being acids or bases.